Hello everyone, I am Kumari Amita Singh, a PhD scholar in Department of Dairy Science and Food Technology. Today, I am here to discuss a very interesting topic, that is color characterization in food. So let us start. These are the overviews of the topic. Now, I would like to describe about the food colors. According to FDA, a color is an additive and is defined as any dye, pigment, or other substances that can impart color to a food, drug, or cosmetic, or to the human body. It comes in many forms such as liquid, powders, gels, and paste. It is used in both commercial as well as in domestic cooking. Food colors are added to food or drink to change its color so that its acceptability can be increased. Color is one of those important ingredients upon which flavor and quality of the food can be judged. Today's consumers are proactively seeking food products which contain safe ingredients in them. They also want absence of adverse reactions either on regular or prolonged consumption. Now, I would like to brief about the history of the food colors. In the earliest record of the use of natural dyes were found in China in 2600 BC. In 2500 BC, dyeing was known in the Indus Valley period. Saffron is mentioned in the Bible. In 400 BC, Egyptians colored candy and wine were there. In 1800, the developing food industry had a vast array of colors. In 1856, Sir William Henry Perkin developed first synthetic color, that is mauve. In 19th century, the beginning of the 19th century was remarked for the bulk production of synthetic colors from the petroleum derived products like alanine, therefore they were called coal tar colors. Now, what is the purpose of the food colors? People associate certain food with certain color and the color of food can influence the perceived flavor in any food product. Color additives are used in food for many reasons such as to make food more attractive, appealing, appetizing as well as informative. It is also used for offsetting color loss occurred during the processing or due to the exposure to air, light, temperature extremes, moisture as well as storage conditions. It improves appearance, taste, texture, nutritional value, safety and freshness of the product. It also influences consumer to buy a product through visual perception. What are the attributes of the colors? Each color has its own appearance based on the three key attributes, that is hue, chroma, and value. Hue is defined as how most of us perceive and name a color using the colors of the rainbow, that is red, orange, green, blue, and etc. Chroma, also known as saturation, describes the vividness or dullness of color. Take a look at the photo below. The orange on the right is vivid, while the carrot on the left appears to be more dull. Notice on the color wheel above that each color starts from gray, that is dull, in the center and becomes more saturated, that is vivid, towards the outside of the wheel. Values. Value is the degree of a color's lightness and describes the luminous intensity of a color. Notice in the photo in the previous slide, the orange appears to be lighter in color. Intensity. Color intensity often refers to the brightness and visibility of a product, and when it comes to food, color can greatly influence both taste, perception, and acceptability. Now, the classification of the food colors. It is basically classified into four classes, that is natural colors, in which pigments made by living organisms are called natural colors. Examples: anthocyanins, carotenoids, and annatto. Now, the nature identical colors, which are man-made pigments which are also found in nature. Example: beta carotene and canthaxanthin. Artificial colors. They are purely man-made colors. Example: indigo carmine, allura red, brilliant blue, etc. It has no evidence in the natural, uh, in the nature. Now, the inorganic colors, made up of mineral compounds. Example: titanium dioxide, gold, and silver. Classification of food. Depending on how light acts, food products can be classified as opaque, translucent, or transparent. Opaque foods such as crackers, cornflakes, cheese puffs, flour, tomato, juice, cheese, and meat are seen wholly, by reflected light. The most difficult aspect of color sampling of opaque food is the presentation of the sample to the light path. Readings are taken at different angles than averaged. Translucent foods. Translucent foods such as fruit juices, jams, and custards are seen partially by reflected light and partially by transmitted light. Translucent foods are typically in liquid or semi-solid form, and sampling requires special handling. The color of a translucent sample will change when the light path length through it is changed. Thus, the path length must be fixed with a fixed white background. Transparent foods are typically liquids or semi-solids such as clear juices, wines, jellies, gelatins, vegetable oil, and soft drinks are seen wholly by a transmitted light. Products such as clear juice, soft drink, vegetable oil, and brewed tea are poured into a transmission cell for sampling. The sample cell is then placed against the sphere port in the transmission compartment of an instrument. Color measurement. There are basically two principles of color measurement, that is colorimetry and spectrophotometry. Let us understand about the colorimeters. Tristimulus filter colorimeters are designed to produce the psychophysical sensation of the human eye's view of color. These colorimeters are sensors that stimulate the way the human eyes see color and quantify color difference between a standard and a production sample. While colorimeters have sensitivities corresponding to the human eye, they always take measurements using the same light source and illumination method. As a result, the measurement conditions will be the same regardless of whether it's day or night, indoors or outdoors. Now let us understand about the tristimulus. The amount of red, green and blue needed to form any particular color are called the tristimulus values and are generally denoted by X, Y and Z respectively. The most commonly used notations are the CIE, X, Y, Z. Let us understand about the spectrophotometers. Spectrophotometers measures a ratio of the light reflected or transmitted from a food product to that known from a known reference standard. Spectrophotometers are more accurate and more expensive than colorimeters. A spectrophotometer works best for liquids and for transmission. The choice of which instrument to use will depend on the food material and type of application. Colorimeters can be used as a rapid qualitative analysis technique to monitor product quality during each processing step. Uh, why we measure colors? Color is a key component to enhance the ultimate appetizing value and consumer acceptance towards foods and beverages. Synthetic food colors have been increasingly used than natural food colors by food manufacturers to attain certain properties such as low cost, improved appearance, high color intensity, more color stability, and uniformity. Color is an important quality attribute in the food and bioprocess industries, and it influences consumers' choice and preferences. Food color is governed by the chemical, biochemical, microbial, and physical changes which occur during growth, maturation, post-harvest handling, and processing. Color measurement of food products has been used as an indirect measure of other quality attributes such as flavor and contents of pigments because it is simpler, faster, and correlates well with physiochemical properties. Since visual color judgments can be affected by a wide variety of factors from plant lighting conditions and angle of observation to individual differences in color perception. Instrumentation to measure color provides a subjective and consistent method of color quality control. Color measurement systems are used to measure a broad range of food products. These include fresh and processed fruits and vegetables, formulated foods, dairy products, meat products, spices and flavors, cereals and grains, oils, syrups, sugar, and beverages. Visible light is found between 380 nanometer to 780 nanometer in the electromagnetic spectrum. It is bordered by ultraviolet light on the low end and infrared light on the upper end. When light strikes an object, it is reflected, absorbed, or transmitted. Because reflected light determines the color of a material, the appearance can change depending on amount of light, the light source, the observer's angle of view, size, and background differences. Now we will understand about the color scales. There are basically five types of color scales, that is Munsell color system, CIE color system, CIE lab, Hunter lab and Lovie-Bond color system. So let us understand these color scales one by one. First, we will look about the Munsell color system. The Munsell color order system is a way of specifying colors and showing the relationship among them. Every color has a three qualities or attributes, that is hue, value and chroma. Munsell established numeric scales with visually uniform steps for each of these attributes. As we can see these scales from this picture. The color of any surface can be identified by comparing it to the chips under proper illumination and viewing conditions. The color is then identified by its hue, value and chroma. CIE scale. The CIE system is the most influential system for the description of color. It is based on using a standard source of illumination and a standard observer. The CIE obtains CIE standard observer curves for the visible spectrum for the stimulus values, which are converted to the unreal primaries, that is X, Y and Z. CIE lab system. The CIE lab color system represents quantitative relationship of colors on three axes. L value indicates lightness and A and B are chromaticity coordinates. On the color space diagram, L is represented on a vertical axis with values from 0 to 100. 0 represents the black color and 100 represents the white color. As we can see these things from this picture, the A value indicates red-green component of a color, where PA positive and AA negative indicates red and green values respectively. The yellow and blue components are represented on the B axis as PB positive and AB negative values respectively. At the center of the plane is neutral or achromatic. The distance from the central axis represents the chroma or saturation of the color. The angle on the chromaticity axis represents the hue. Hunter lab. Hunter lab and the modified CIE system called CIE lab color scales are opponent type systems commonly used in the food industry. The system measures the degree of lightness L, the degree of redness or greenness positive and negative A, and the degree of yellowness or blueness, that is positive and negative B, as we can see these things from this picture clearly. Lovie-Bond. The Lovie-Bond scale is based on 84 calibrated glass color standards of different densities of magenta, that is red, yellow, blue and neutral, graduating from desaturated to fully saturated. Sample colors are matched by a suitable combination of the three primary colors together with neutral filters, resulting in a set of Lovie-Bond red, yellow, blue and neutral units that define the color. So these are the some references from where I took help to prepare these slides. Thank you for watching my video.